you got to hit letters. Like, I have no idea what letters they are. I just hit the button and slide my finger along, Q across to P, and then whatever ones I like, I keep. I have no idea what 3 letters those are. But I like this one right here because it looks like the voice. Except it's not. It's a hand reaching out from a grave. I was worried you guys might be scared by it. I'm kidding, Jake. It's a font. There is nothing to be scared of. All right. Of course, you combine the bottom here to get 2a squared, and then you canceled one of the a's. And then you cubed it all to get 1 over 8a cubed. To get 1 out of 1. And then here, of course, you remembered this is multiply to get b6. And you remembered this is add to get b7 with a 2. And then you canceled 6 of them. And you were left with 1 on the bottom. So it was 1 over 2b. C. Now, this is when I pause, so when they tell me that they pay attention in class, I can say that they don't. Because as you can hear, you're a very high quality microphone. You can hear the fact that nobody in here is working. I know you did. I just like to have evidence for when parents come in and say, my kid pays attention in class. Oh, does he? I know who it is, Yunji. And in a moment, I will actually name names on the microphone. But I like to give them a chance to recognize that they should be paying attention. I like to give Riley Van Dam and Jack Anderson a chance to recognize that it is time to shut their pie holes and do math.
At this point, Jack has stopped, though.
I know, but I'd already started my sentence, so I had to stick it out.
You just made fun of Riley.
I could have just made fun of Riley. But I also didn't say anything for the first minute of your people's conversation. Actually, I said a lot, but you didn't hear because you weren't paying attention. This one, of course, are you worried about all these negative exponents? No, of course not, because they may take care of themselves at the end. And you would notice down here on the bottom, you have that, which makes negative 12. And then you have that, which makes negative 14. 2k. And then you had 2k to the negative 2. Then you recognized, oh, wait a minute. Those 2's disappear. And then you saw, wait a minute, negative 2 minus 14 is k to the positive 12. Oh my goodness, they did take care of themselves. A. Then we get to this one. And hey, wait a minute, that looks exactly like this one. So we followed the same rules. We dealt with that to get negative 4. And then we noticed 4 and negative 4 makes p to the 0, which we know means this is over 1. And once anything is over 1, we don't even write the over 1 part of it. And all that was left was 2p3, which was right there. How did I get? What is negative 2 minus negative 14? What does that negative do here? So it makes it negative 2 plus 14. And finally, this guy right here, tricky because that 3 has to go to everybody. So it's x4 over 8 x9 and one more x. So it was x4 over 8x10. Then, of course, you subtracted and got 8 on the bottom, 1 on the top, and x6 down there, which was D as in doornail. Then you turn the page over and you recognize this was 16 times 6, which of course meant you took out the square root and got 4 root 6. If you had to go in a different way from here, is that okay? Of course it is. Could you have broken down 96 into 12 and 8 and then carried on? Yes, but what will happen? You will still get the same answer if you did it right. Okay, 24 and 4 would also work. But then you would have had 24 and 4, and then you would have recognized that this was 6 and 4, and there was your pair of 4s. Out came the 4, leaving a 6 under there. This one, of course, was 9 times 5. Out comes the square root of 9, 3 root 5. This one was, of course, 16 times 2. Out comes the square root of 16, 4 root 2. This one is, of course, 16 times 5. Out comes the 4. Oh, but what was already out there? 6. So we add 24 root 5. This one was 21 times 7, which broke down again to 7 and 3. There's your pair. So what comes out? 7. What was already out there? So it's negative 56 root 3. This one is, of course, 25 times 3, so out comes 5. But what was already out there? 2, so it's 10 root 3. And now we get to the trouble. Well, that shouldn't have happened. Now, if there were no letters there, could you do this question?
Yeah.
Of course you could, because you would break down the 343. And when you broke it down, you would get it was 7 times 49. And why would you stop there? 49's got a perfect square, so what comes out? 7. But there was other stuff there. What else was there? How many groups of 2a's can you get out? 2. A squared. How many groups of b's? 1. So b. And what was already out there? A negative 7. What do I do with all of that? Multiply it to get negative 49a squared b. And what did I leave under there?
7.
Just a 7. Come over to here and I do the same thing. That's 64 times 2. Why do I stop there? 64 is a perfect square. What comes out? 8. How many u's come out? 1. How many v's? 2. What was already out there? So what's the answer out front? Negative 40u v squared. And what did I leave under there? Close. 2u. Because you left that 2 and you left one of those u's. And finally, this one is, of course, 16 times 2. So what comes out? 4. How many a's? A squared. Any b's? No. And what was already out there? Negative 5. So it's negative 20a squared. And what did I leave under there? 2b. Giving you a new mark out of 14. Now, no pressure. How many people improved? Then you improved. You didn't have a mark before, and now you have a mark. I will come around later when you're working and get your new grade out of 14. Once again, hopefully proving to all of them that if you practice the same thing 2 days in a row, you do better the second time. Imagine.
Crazy.
I know. The next thing I left for you to do was pages 102 and 103, to which your TOC responded. Most of them were done up to page 103 already, so there wasn't much for them to do. That was weird. I told you on Thursday you didn't have to do any homework, so you did homework. So let me get this straight. Just to be sure, when I say do the homework and I do this homework check and I get that many X's, but when I say don't do the homework, all of you did it. Just making sure. Well, I know that. All right. Just making sure that we're on opposite days all the time now. So, the answers are right here, highlighted in yellow and green up to number 7 on page 102. All the work is there as well, but the answers are what is highlighted. You may have done it a different way than me, so again, I don't really care if all the work is different, but I do care if you're not getting the right answer. So, does anybody need anything explained up to and including number 7? Riley. Which one? Which one?
3. That one looks the most complicated.
3? Okay.
Oh, wait, sorry. 5, sorry.
5. Okay. Okay. So you could have gone 3 times 2 times 2 to get 12. Cubed root. 16 times 4 is 64 times 2 is 128. You could have done that and then simplified the 128. But 128 is kind of a big number, so I always like to simplify at the beginning. This is 8 times 2, yes? Why did I choose 8? Because 8 has a cube root. What is it? 2. 2 times 2 times 2, right? So what comes out? 2. What was already out there? 3. So I add 6. I had 6. I had 6 cube root 2, right? And then this guy doesn't get any smaller, 2 cube root 4. And this guy doesn't get any smaller, 2 cube root 2. 6 times 2 times 2 is 24. 2 times 2 times 4 is 16. Now we already know that 16 is 8 and 2, so I brought out the 2 to get 48 cube root. What did I leave under there? 2. Okay? Now, if you had gone the other way, and you said, I don't like simplifying first, Mr. Myers, I like to make my work more difficult, then you would have had 12 cube root 128, and you would have had to break down 128. Now, for me, that's easy, because I know it's 64 times 2, and I'm going to stop at 64, because I know 64 has a cube root, and it's 4. But you guys probably don't, so you would have to break 64 down into 2s, then take out groups of 4. Or groups of 3. I wouldn't do that. Out would come 4. 4 times 12 is 48 cube root, and I'm left with a 2 under there. Either way, I end up with the same answer. But that's because I know some more perfect cubes and squares and things than most of you guys do. If you had to break 128 all the way down, you end up at 2 to the 7th, 8th, right? And that's a pain. And there is 6 through 11. Doesn't quite fit on the page. Oh, yeah, it does, because you saw 6 and 7 already. There's 8, 9, 10, 11. The answers are in blue. The first step that I would have expected most of you to get to is in yellow. I mean, ideally, you should be getting to the blue anyway. Brianna. Yes. Okay. So, first of all, for 9, 10, 11, and 12, you will notice that it was adding and subtracting, yes? And I didn't actually teach you that, but I did go out of my way to explain that the principles here, 3 root 5, follows the same rules as 3x, yes? I have notes on that, right? That's how we learned how to multiply. Because if we did 3 root 5 times 4 root 6, we knew that it was the same as doing 3 times 4, x and y, and our answer ends up being 12xy, right? Yeah? There we go. So, because this is how this works, I wanted to see if you guys would do the thing that you should be doing right now, which is if I know something about math, then I know it's going to work again. If I had 2 x's and I added 3 more x's, how many x's would I have? 5 x's, right? That's okay. What happens if I have this? 2x plus 3y. No. You can't do it. Why? They're not the same term, are they? So, look at this situation here. I can't add these because they're all different, yes? So I do the only math I know what to do here, and that's simplify radicals, right? Okay, so that is 5 times 4, yes? Right? 4 has a square root. It's 2, so out comes 2. 2 root 5. Everybody good? And this guy is 36 times 2, yes? So 36 has a square root. What's that? 6. So out comes a 6, and we left a 2, yes? And this guy is 9 times 5, right? What's the square root of 9? So out comes a 3, right? Now, okay, I've done all my simplifying. I don't know what to do now. Oh, wait a minute. I got 2 root 5s right there, and I'm taking away 3 root 5s right there. Well, if I got 2 coffee cups, and I take away 3 coffee cups, I'm at -1 coffee cup, right? If I have 2 x's, and I take away 3 x's, I'm at -1 x, yes? So if I have 2 root 5s and I take away 3 root 5s, I must be at -1 root 5. Would I ever write that one? No. And then 6 root 2 had nobody else to play with, so it stayed by itself. Now, I never showed you that, which is why I showed you the work and highlighted the stuff in yellow. Because that is where you should have been able to get to without me. Hopefully some of you remembered what I say all the time. If it works once in math, it always works. And you put it together. If you didn't, it's no big deal because I'm not marking you on this, am I? Is this getting a mark? I didn't even do a homework check for it, did I? So what does it matter? It's stuff you got to know. Now you know it, but you already knew it because you already knew how to add coefficients and variables. So that's what was happening here. If you got to the yellow, which was where you got simplifying everything, I'm super happy. But, of course, -5 plus 3 is -2. because I got root 15s there and another root 15 there. That's why all this is in yellow and in blue. Everybody good? Lovely. Next page was this page. More practice. There's up to number 8. Please check your work. Don't bother writing down the right answer if you didn't do it, because this is getting recorded and you can check it later. Of course, if you only just didn't do 1 or 2 of them, you could copy them down. I don't mind that. And there's 9 to 13. Again, if you only got to the blue lines, that's okay. But you should have been able to figure out how to get to the yellow lines. Okay? Okay. Please open your booklets to page 104. And you will all need your calculators out or access to it. But I haven't been here since Thursday. I got some. No. Then you probably shouldn't take one of these. Just look on Mason's. All right. Couple of things. 1, this word right here, it's not a real word. Okay? I put it there to remind you that we are going to have exponents that are fractions. But in actual math, we call these rational exponents. Because even though all the exponents we've dealt with are rational, when we say rational exponents, we specifically mean this scenario. Okay? Now, in all the other exponent work we have done, we've been able to write out what is happening, right? For example, x squared we know is x times x, right? 13 squared we know is 13 times 13, right? 2x squared, we know what it is. It's 2x times 2x, yeah? Okay. We've been able to explain it. And we even use this to explain negative exponents, which make no sense, correct? So now, looking at what we have here, this is saying, what's the base? 9. And it is saying that I'm going to multiply 9 by itself half a time. Does that make any sense? No. So we're going to do something here that I don't normally do. We are going to prove something backwards. And here's what you are going to do while I wait for my computer to thaw. You're going to get out your calculator. You're looking at it right now, yes? Find your exponent button. Make sure you know where it is. The exponent button is either the x to the y to the x, or the little mountain thing. And I want you to take this expression and enter it thusly. When I say thusly, I want you to punch these buttons. 9, exponent button, bracket, 1 divided by 2, bracket, equals. And if you have done this correctly, you get 3. Yes? Excellent. I want you to do the same thing for 27 and 625. Go. Yes, there is definitely something wrong with it. No, you typed it in wrong. You forgot the second bracket. No. What is this one? 3. What is this one? 5. Now, we are going to take a moment to look at this situation. We are going to use just this example right now. In this yellow highlighted box, you see 3 things that you know. What do you call this big number beside an exponent? A base. But it is also a natural number. Thank you. And what do you see here? An exponent. And here you see an answer, yes? Now, you guys are smart kids. Is there a relationship between 3, a power, and 9? What is it? 3 squared is 9, yes? So, 3 squared equals 9, which means the square root. Wake up. Wake up. Wake up. The square root of 9 equals what? 3. Everybody cool with that? Now, according to this piece of information we just got right here, 3 also equals 9 to the 1/2. Yes?
Yes.
So what does that tell us about this expression and this expression? They are the same thing. So we can go ahead and erase that 3 in the middle, and we can say that the square root of 9 equals 9 to the 1/2. Yes?
Yeah.
Now, hopefully you guys are smart enough to see this as well. What number is that? 2. What number should be right there? 2. What number is that? 1. What number should be right there? 1. Number that we don't write. Correct? Everybody cool? Okay. Now, is there a relationship between 3, an exponent, and 27? What is it? 3 cubed equals 27, yes? Which must mean the cubed root of 27 equals 3, yes? What else equals 3? 27 to what power? 1/3. If that equals 3 and that equals 3, what do I know about that? That it's the same. What number is there? 3. What number is there? 3. What number is there? 1. What number should be above 27 that we never write? 1. Are you seeing what you should be seeing here? I hope so. What about this situation? What is 5 to the 4th power? 625, which must mean the 4th root of 625 is 5, yes? Which must also mean that 625 to the 1/4 is also 5. Does everybody see that pattern? Has it happened more than once in math? It's happened 3 times. If it's happened 3 times, what can we say about it? That it's always going to happen. Let's put it in terms that always work. X to the a over b. Any number to an exponent that has a fraction. Where does the b go? Notice in all our examples, the 3 became the 3, the 4 went to 4, the 2 went to 2. It becomes the root. The proper word for that is the index. So it becomes the b root of what number? X, the base, to what power? A.
What the? Okay, but
Does it always work? Yes, because we just proved it. Now, your guys' book printed weird, so did mine. For some reason, B is right up here. I'm just going to cross it out and move it down a little lower so we can work with it. And it's to the 4/3, yes? All right. Now, please notice I have done something that for all of you is very, very frightening. I have given you the scariest instruction that can be given to a math class in 2017.
no cheating.
No.
Calculator?
Oh, I didn't see that. Uh-oh, Sam's already done it.
See, I knew it.
Oh no. That is utterly frightening.
Can't cheat our way through it.
I'm sorry I did the first one.
Don't care, you're going to be doing them properly now. So, let us begin, shall we, cabbages? This number right here is yucky. But it's really 4 over 100, isn't it? Okay. So that is to that power, correct? Does this look like this? Is there a base? Yes. Is there an exponent? Yes. So where does the denominator of that exponent go? I'll say it again for the people. It becomes the square root of what? 4 over 100, all to what power? 3. What is the square root of 4? 2. What is the square root of 100? 10. All that is cubed. What is 2 cubed? 8. What is 10 cubed? 1,000. And now it is done in your head without touching your calculator. You should. Let's look at B. Does B look exactly like our example? Okay. So where does that 3 go?
On the index.
Excellent. And what becomes my radicand? 27. And what power do we put that expression to? 4. Now let's say you are a bad math student, and I don't mean poor at math, I mean you didn't do what you were told, and memorize your cube roots. Well, then all you would do is you would break this down and realize it was 3 times 3 times 3. And you're looking for a group of 3, aren't you?
Oh, yeah.
So what is the cube root of 27? 3 to what power? 4, which means 3 times 3 times 3 times 3, which we are going to do in our head. 9 times 9. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Everybody good? All right. Let's look at C. Does C look like this? Kinda. Because if this wasn't here, it's easy, isn't it? What is this part of it. Isn't that just the cubed root of 8? To the first power, right? What is the cubed root of 8? 2 to the first power, which is what? 2. But all that is squared. So what's my final answer? 4. Does everybody see what is happening here? And you're not even using your calculators. At least, I hope not. Good. All right, let's look at D. What's weird about D? Because you're not allowed to use your calculator. It's a decimal, so what should we do? 49 over 100 to the 1/2. Where does the 2 go? It's the root. Where does the base go? To the radicand. And all that is to what power? 1. What's the square root of 49? Over what? 10. To the first power. Do I write it to the first power? No. So it's done. But isn't that also 0.7? What's weird about E? It's got a decimal exponent. Turn it into a fraction. To what? 16 to the 3/2. Does that now look exactly like our that? So where does the 2 go? What? Brianna said wait. Well, what's 1.5 as a fraction? Isn't it 1.5? 1.5? And isn't 1.5 3/2? Okay. Where does the 2 go?
Goes as the
Index. Where does the base go? Radicand. Exponent. What is the square root of 16? 4 to the 3rd power, which is what? 64. What's weird about F? It's another decimal, yes? 3/4. So I need the 4th root of what? 81 cubed. What? Okay. What is the 4th root of 81? What? We know that's 9 and 9, and we know that's 3 and 3 and 3 and 3. Is there a group of 4? So the 4th root of 81 must be 3, yes? 3 cubed. What's 3 cubed? And I'm done. Now, what is this actually saying? It wants what? Just when you see that, what does it mean? It means 5, the 5th root of 8, squared, because it looks the same, yes? You can't. Because 8 doesn't have a 5th root, does it? What's the biggest root we can get out of 8? A cube root, right? Because 2 times 2 times 2. So we know that this is irrational. If it's irrational, then where do we have to go to get our answers? To the calculator. How would I put this into a calculator? You've already practiced it at the beginning when we proved it. 8, exponent, bracket. What do I put in the brackets? 2 divided by 5. And then what must I remember to do or I will get the wrong answer? Close the brackets. And then hit equals. Now, this is going to be interesting. It's going to give you a weird number. It's going to fill your calculator screen. I got it right here. Right there. Right? Most of your calculators will end at the 1. Some of you might have 10-digit display. Does anybody go past the 1? Yours is stopped? You have a 10-digit? No. Don't look at the sun. Don't. All right. So, is this the answer? Or is it a guess? Okay. So, if I asked you to write this down, how many of you would write out all 10 digits? You don't need to. Most of you would round that off. Some of you would round it to 2.3. Some of you would round it to 2.29. Some of you would round it, and this is what I'm looking for you guys to get. The first number that it's not going to bump up the next one is the 3, yes? So the best answer here, and I got to use the squiggly equals because I'm not going to give the right answer, is 2.297. And I'm stopping there because the 3 doesn't bump it. Does everybody understand? I'm trying to get away from the, how many decimal places is from Myers? Okay? Because I don't care. What's the next one going to be? What are you going to punch into your calculator? 0.6. Exponent. Bracket. 15 divided by 7. And get what? I've got it on my calculator already. 0.3346646. So where should we stop? 0.33 would be fine. Would I use an equal sign or would I use the squiggly sign? I'd use the squiggly sign. What does that tell me as your math teacher? It tells me that you've rounded. Okay? So if you're doing a big question that requires a lot of work, and you show me the squiggly equals somewhere in your work, what does that tell me you did right there? You rounded. So if your answer is different from mine, I can go back and say, oh, they rounded there. Oh, that makes sense. Okay. Does everybody understand? It's very helpful for me when I'm marking your work to follow along your thinking so I can help you out. Everybody cool? All right. Turn the page over. And now we're going to actually apply what we just learned with our calculator to a scientific situation. How will I punch this into my calculator? Where does the 27 go? For M. So the brain mass of the dog is 0.01 times 27 to the 2/3. Punch that into your calculator and see if you can get the right answer. I know what it is. I will know it when I hear it. 0.09 kilograms. Yes. You didn't actually even need your calculator, did you? Because the cubed root of 27 is 3. 3 squared is 9. Move it 2 decimal places, 0.09. Can you do that with 200? 200 as a cube root? Can't do it in your head here, can you? You got to punch it in. Try it. Make sure you can make your calculator do the right work. Because in math class, your math teacher often gives you stuff you can do in your head without a calculator, right? We just did a whole page of it, yeah? But when you're out in physics or chemistry or biology, it's not the way it works. So you still got to be able to do the math on the machine, and doing the math without your calculator actually helps you get the concepts down. So what's that one? Yeah, I didn't fool anybody. Approximately 0.34. And what was this one for yourself? 0.15. Yay! Now, listen please. We're gonna do something a little weird here. No. This page, please write on yours, on your page 106, please write on there, do this. I'm going to explain how it's different, Nick. Then turn past that page. On to 108, I believe, is the next thing that has work.
107.
107 has answers.
Oh, 108.
108. Without a calculator. Now listen to me. We are going to go through this page without our calculators. And then I'm going to show you what I mean by what's a little different here. Now this scares you right away. You want to get your calculator. Why? Because it's decimals and exponents. Barf. But do you need to? No, because what do you notice about that and that? They're the same base. What do I get to do with the exponents? Add them together. What's 5 take away 3? Squared. Still have trouble doing that in our heads, I bet. But 0.3, isn't that just 3 over 10? Squared is what? 9 over 100. And I'm done. But it's also what decimal? 0.09. Now you should notice something. 3 squared is 9, but don't forget, this is 3/10. So I also got to square the tenths to get the 900ths. Yes? Now, everybody look at number 2. How many of you look at number 2 and say, yuck, I'm scared? Be honest. It looks scary, doesn't it? Until you look real close and see what? They're the same base. So do all our exponent rules apply? What do I do right here? Times to get -8, right? What do I do right here? Times to get 6. 3 times 2. What do I do right here when I'm multiplying? Add. What's -8 plus 6? -2. What does -2 do to any fraction?
Makes it positive.
No. What does a -2 exponent do to any fraction? Flips it over. So it was -3 over 2, so what does it become? No. It becomes -2/3 to the positive 2. What is -2 squared? What's 3 squared? This is what's going to stump you guys? 9. What do you mean, where's the negative? It takes care of itself because the negative is squared out right there. Right? That's my point. I want you guys to look at something that looks frightening and say, no, wait a minute. I can deal with that. It's got the same base. I know all my rules. As a matter of fact, would I have been allowed to write this as x and x to deal with all the exponents? Would that have been okay? Sure. And then you would have gotten to this point right here. X to the -2. Oh, -2 means we flip. X was that fraction, so I flip it. Right? Okay, what's happening down here? Whoa, 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 Tasha, what?
You lost me at the flip it part. I don't know what you mean. Like, I remember, like, talking about it, but, like, I don't know.
A negative exponent does what to its fraction? Or any number? Right? Yeah, if I have 7 to the negative 2, that's really 7 over 1, isn't it?
Yeah.
So it becomes 1 over 7 to the positive 2. They just flip.
Oh, okay, yeah. Okay.
Okay. So let's look at E, or 3. Looks scary, but is it?
No,
Why?
because it's all the same.
It's all the same base. What do I do up top?
Add
1.4 to the what?
3,
7 over 1.4 to the negative 2, which is?
1.45.
No. 1.4 to the 9. What about this one? Should 4 scare you?
No,
It will. I'll give that on a test, and you guys will leave it blank. Why should you not?
because the numerators.
It's all the same base, right? What's 1/3 and 5/3?
6/3.
7 to the 6/3. Same base, right? If I got 2/3 and I take away 6/3, what have I got?
-4.
7 to the negative 4/3, yes? What does the negative exponent do to its base? Flip over. So instead of 7 over 1, what does it become? 1 over 7 to what power? 4/3. Can I leave it like that? Or is there one other way I could write it? Don't I know it's something there?
Yes.
What does that 3 become?
The index.
Index to what root?
7.
1/7 to what power?
4.
4. These are the same. Well, all you need to know, Josh, is this is what we just did. The exponent became the radical. The base went under there. And that part of the exponent became the power. It's exactly what we just did. It just looks different because you guys get scared by looks. I don't know why. If there was no y there, what would you do with those x's? To get what? To the 5th. If there was no x there, what would you do with those y's? To get y to the what? What part of that isn't allowed?
Move it down to the bottom where it belongs.
And it's done. Language, please, gentlemen. There's. Pardon me? Why is it -2 or why does it move? Okay. Okay. Yes. Well, again, no. See, Brianna, this is the problem here. Please, 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 watch. 2 squared is 4, yes? 2 to the 1 is 2, yes? What is the next logical exponent here? 2 to the what?
0.
0. This has been divided by 2 every time, yes? So this must be divided by 2. 2 divided by 2 is 1, yes? What is the next logical exponent? 2 to the negative 1, which means I must divide by 2 again, yes? So I get 1 over 2. 1 divided by 2. Next logical exponent is 2 to the negative 2, yes? 1/2 divided by 2 is 1/4. So please notice, that the negative 2 squared is 4, but it has to be a quarter. That is why the negative exponents move. Now the problem here is when you guys see a negative exponent already in the denominator, because all you have learned, all you have listened to and taken away from me is negative exponent's got to move to the bottom. But that's already on the bottom. So where would he go? Back to the numerator. So what is this? A to the negative 3 over b to the negative 7. B to the 7 over a to the 3. What is this? B over a, b cubed over a to the negative 2. What's that?
Whoa.
A to the 2, well, just leave it as squared for now, Sam. Over what? B3. And then Sam finished it up with a squared over b6. Everybody cool? Now there's one other problem with negative exponents that screw you guys up.
Scary exponents.
No. It's when it looks like this.
Oh wait, a to the 6, b to the 6. No, a to 6, b to the negative 6.
Flip it. B squared over a to the what? It stays negative because when you flip it, what's the only exponent you're changing? The outside one. Now I get b6 over a to the negative 6, and then what?
Bring that a up there.
Bring the a up. Oh, I heard what he said,
Be a party.
which wasn't what you said. I didn't hear that. So do not get trapped in the negatives move to the bottom. Please put that A in there. I don't know why it didn't print. What are you going to do with the 10 and the 5? To get what? 2. Is there anybody that doesn't understand that step? That's not what I asked, but okay. What are you going to do with a to the 5th over a cubed? Okay. You're going to subtract the exponents because that is division. Right? Yes. So what are you going to get? A2. What are you going to do with b to the 3rd and b to the negative 2? No. No. Well, you could flip. If you flipped, what's moving? The 2 is going to move up and become positive, yes? Which means what can I do now? Add them, because this is now multiply instead of divide. And I would get b to the 5th. Now the other thing you can do here is remember that this can also be subtraction of exponents, yes? Which is 3 minus negative 2, which is the same as 3 plus 2, which is the same as 5. Okay? Good? All right, let's go to the next one. It's frozen anyway. You got some time. What do you notice about 7? It looks scary, but it isn't, is it? Why?
Because it's not the stuff we already know.
Everything's the same base, right?
Oh, yeah.
Negative exponents scare me, Mr. Myers. So try to get rid of them. What do you do over brackets?
You multiply.
Multiply. What is negative 5 times negative 3? Positive 15. Is our negative exponent gone? Yeah. What do I do here? Subtract 1.5 to the 10th. Am I happy? Yeah. Look at 8. What do we know about the 1/3 as an exponent? You can. There's 3 things I could do here. Somebody give me one of them. Jack.
So it's 8 is 3, but you multiply it by 1/3 to be 8 to the 1.
8. Oh, A. Yes. But what about the 8?
No, I don't know. That's where you lost me.
2.
Oh, 2. Yeah, I guess that's right.
8 to the 1/3. Yes.
Yes.
And then A. Jack says it's to the 1. Why? Because I'm going over brackets. And what is 3 times 1/3? 1. So what do I do with B?
You do the same thing. Except
I'm going over brackets.
it's B squared.
But it's going to be 6/3, isn't it? Which is really what? 2. Now, what do I know about this situation?
That,
Isn't that the cubed root of 8 to the first power?
yeah.
What's the cubed root of 8? 2. A. Do I write A to the 1?
No. You correct.
B to the
2.
2. Am I done?
Yes.
Yes. Very difficult question. Can everybody follow it?
Yes.
Which part, Tasha?
I get it. No, like I understand like when you talk through it, but like I know that like if I have to do that,
Okay, so this is something that I don't understand about you guys. You all say, if someone's talking us through it, I can do it. And yet when I watch you do your work, none of you talk to yourselves. I know you laugh, Jashin, but you can all read a book without actually speaking out loud, right? You talk it through in your head. Okay, I need to multiply over the brackets. That's a 1. 1 times 1/3 is 1/3. Right? Say it in your heads the way you would read a book. What am I doing here?
Yours.
Is there a better way I could write that to make it look less scary?
Yes.
Couldn't I write 4 over 2? A to the negative 2 over A squared. And B to the 2/3 over B to the 1/3.
And you get 2.
Well, what's 4 divided by 2? 2. What do I do with these exponents?
They cancel out.
No, they do not.
Oh, it's A to the 0. It's 1.
Don't yell out answers. Talk to yourselves. What do you do with exponents when you divide?
Try.
Great. So take that exponent, which is negative 2, and subtract 2 more from it. Stop and think before you yell out 0, because I've said 4 times it's not 0. What is negative 2 and then 2 more negatives? Negative 4. 2/3 take away 1/3. 1/3. What of those 3 do you not like? A to the negative 4 has to be where? In a denominator. Can I write B to the 1/3 in a slightly different way? If I wanted to. What would it be? No. Where does the denominator go? Index. What goes there? B to what power? 1 over A to the 4th. Now 10 should scare the poop out of you. 10 looks very frightening, doesn't it? So let's stop and think for a second. What could I do to tidy this up? You want to get rid of that? No problem. That would get me, what is 100? It's going to be 100 to the half, isn't it? And that's going to be a to the 5 halves. Yes, because that's 1. Sorry. A to the 1 half. Yes? Right? Over. Does the 25 get the 1 half? It's part of the brackets. Yes? And what do I do here? That is going to be a to the 5 halves. Yes? Right? Because 5 times 1 half is 5 halves. Yes? And b to the what? 1 half times 1 half is?
2.
No. 1 half times 1 half, guys. 1 half times 1 half. No. 1 quarter.
Why do you have to say it?
You guys have to think it through your heads. Don't yell it out loud.
When something is to the half, it's a square root, isn't it? Isn't it? So what's the square root of 100? 10. What's the square root of 25? 5. What's 10 divided by 5? 2. What math do I do with the exponents here? So that's a to the 1 half, take away 5 halves. A to the, not quite. That is a to the negative. Sam, you said 3 different things. Choose one. Negative 2. Excellent. And is there anything else happening with b's? So he is going to live down here. What part of all that do I not like? Is the 2 okay?
Yes.
Is the a okay?
No.
No. Why?
Because it's negative.
It's negative. So he flips from his numerator position to where?
Denominator.
The denominator. Is the b all right? No. So where does he go? To the top. Do that page. We'll finish this. We'll pick this up tomorrow. No, I want you to do that one page I told you to do. We did not get as far as I was hoping to get because of things like 1 half times 1 half equaling 1.